This is a short introduction to the PeriCAT tool, developed by Annegret Eggers from the University of Göttingen for the PERICLES project. In a nutshell, the PERICLES content aggregation tool, or PeriCAT, provides a framework for information encapsulation techniques. Integrating a set of encapsulation techniques from various domains, it provides a mechanism to capture the scenario of the user and to suggest the best fitting information encapsulation technique for that given scenario. There are two main types of encapsulation: packaging techniques and embedding techniques. Information packaging is carried out with, for example, simple archive container formats such as zip or tar, structured packaging for archiving such as Baggett or AVI for video, and metadata schemas such as METS or premise. Information embedding techniques are also numerous, with digital watermarking and steganography being the most prominent. There is a whole range of different software products on the market for steganography and digital watermarking. Steganography basically means the concealment of information within computer files. Other examples of information embedding include XMP, a typical example of metadata embedding, file format features, for example using metadata fields in a file format schema which are empty, and information frames, for example the closing credits of a movie. Now we will move on to a demo of PeriCAT. This is the GitHub page of the project. PeriCAT is an open source tool released under an Apache version 2 license. Here you can browse and reuse the source code. You can also find the release version of PeriCAT. Download either the tar.gz file or the zip file and unpack it. It includes the PeriCAT directory with an executable jar file. PeriCAT needs no further installation, but does require Java 7 to run. PeriCAT has three main tabs: a tab for information encapsulation, a tab for information decapsulation, and a tab to capture the user scenario. Information entities can be aggregated at the Information Encapsulation tab. It also provides an overview of the different encapsulation techniques and the possibility to configure the techniques. As previously discussed, information encapsulation techniques can be categorized in packaging and embedding techniques. Packaging techniques, such as the well-known zip algorithm, use a container file to aggregate the information entities on an equal level, whilst embedding techniques, such as the PNG chunk adding algorithm, use one information entity as carrier and embed the other information entities as payload inside the carrier. Let's start with adding a carrier and payload file. The information encapsulation techniques that can be used for these file types, here a PDF and a text file, are shown in black, whereas techniques which can't be used on these files are displayed in red. We choose the PDF file attaching technique to encapsulate these two files. Here you can see the output file of the encapsulation. If you switch over to the Information Decapsulation tab, you can decapsulate the encapsulated files. This restores the original files and provides some further information about the restoration process. The Scenario tab can be used to capture the user scenario. It provides a mechanism to calculate the best fitting information encapsulation technique for the captured scenario. First, create a new scenario and give it a meaningful name and description. Scenarios can be exported to send them to other PeriCAT users. This enables a better understanding for others regarding the decision made. The scenario is scored according to a series of features. The scores are then mapped to the features of the information encapsulation algorithms to calculate a virtual distance from each algorithm to the captured scenario. Algorithms are displayed with their distances in the high score area. The high score list updates live while creating the scenario and adapts directly to scenario changes so that the user can see the impact of a change. The algorithm with the lowest distance to the scenario is the recommended one. Features can be excluded from the calculation if they are not of relevance to the scenario. For example, moving the weighting slider of one feature completely to one side will grey out the algorithms which do not support the corresponding feature. In this case, only packaging algorithms are considered. The saved scenario can be found in the Scenarios directory. The output directory has the results of the information encapsulation runs, and the restored directory contains the results of the information decapsulations. The GitHub pages provide further documentation of the tool, including a quick start guide, a description of the information encapsulation techniques and the decision mechanism, and information for developers. You can also consult the PERICLES website, where you can download the encapsulation of environment information deliverable, which gives you more details on the background research and the tool itself. PET and PeriCAT form tools to be used for shear curation in connection with appraisal, an activity which might involve assessing which information to keep and encapsulate. Thank you for your attention.